Hi, I'm Richard Booman. I'm an engineer here at Tektronix. One of the most difficult measurements to make on an electrical circuit is measuring high bandwidth differential voltage in the presence of common mode interference, especially when that interference is high frequency interference and in excess of 40 volts. Tektronix's IsoVu measurement system makes this type of measurement possible through its unique combination of exceptionally high common mode rejection ratio, high common mode voltage rating, and high bandwidth. In order to make this measurement while preserving the performance of the IsoVu measurement system, it is important to make sure that the connection to the device under test doesn't degrade the performance any more than is necessary. I'm going to show you several of the connectivity options that we have for the IsoVu measurement system. These are implemented on this demo board. These include using a coaxial Mmcx connector, using standard 25 mil square pins on 100 mil centers, or using some 18 mil round pins on 62 mil centers that we include with the IsoVu accessory kit. We include the adapters necessary to adapt the IsoVu tip cable to these round or square pins and still provide good electrical performance. We've built this demo board with 3 different types of connections. The first and highest performance connection method is to design an Mmcx connector into your device under test. The Mmcx connector is an industry standard connector and is currently available from a number of online retailers at low cost. The Mmcx connector has plenty of bandwidth for our application and provides a shielded coaxial environment all the way to the test point, ensuring the highest common mode rejection and the best performance. The best way to use this type of connector is to design it into your test board as a planned test point. It is also possible to use this type of connector as an unplanned test point, and we will show you how to do that in the next video in this series. One of the other connection techniques that we're introducing is some small 18 mil diameter round pins. We've included these in order to make it easier to measure the voltage drop across an 0402 or smaller size surface mount component. We've also included a tool that can be used for soldering these pins to your DUT straddling an 0402 component. Here's how you can use this tool to attach these pins. The first step is to load the pins into the tool. The tool has been designed to keep the pins parallel with each other and to maintain the correct spacing between the pins so that they fit into the smaller of the 2 square pin adapters that are included in the IsoVu accessory kit. Once the pins have been loaded into the tool, I like to pre-tin the ends of the pins and to re-tin the solder on the attachment point. This ensures that there will be sufficient solder to make a reliable connection and also helps to ensure that we won't have a cold solder joint. We've designed the soldering tool so that it can be used under a standard binocular microscope. Once the pins are loaded in the tool and pre-tinned and the attachment points are resoldered, we can solder the pins to the board. I usually use a microscope or other magnifier when doing this to make sure that the solder has completely reflowed and that the pins are perpendicular to the board. Since these pins are so small, one of the steps we recommend is to reinforce the connection between the pins and the boards with some epoxy. This will help keep the devices and traces on the board from being damaged due to the mechanical stresses introduced by connecting the adapter and tip cable to the DUT. Once the epoxy has cured, we can install the adapter and the tip cable. One of the other accessories that we have provided to help reduce the stress on the DUT is this flexible tripod. This tripod can be placed on the board using an adhesive like hot melt glue or epoxy and can reduce the amount of stress that can be transmitted to the DUT during movement of the sensor head. Now there's a third type of connection on this board, and that uses standard 100 mil spacing square pins. These pins are typically provided in this type of header strip, which can be cut apart to yield the number of pins desired for the particular application. Use of the 100 mil square pin adapter also makes it possible to use any of a number of standard connectivity options that are available that use this type of pin and spacing. It should be noted that depending on exactly how these connection options are implemented, the performance of the test system can be degraded. The user should characterize the attachment method to make sure it is providing the performance that is needed for the measurement. So now with the test points to suit your application installed, you're ready to use the IsoVu system to make high-resolution measurements, taking advantage of the superior common mode rejection and high bandwidth. If you'd like further information, please visit tek.com.